Hello, and welcome to your file processing and exceptions lecture. So throughout this course, we run into a lot of errors when we code. For instance, we might get a zero division error if we ask the user for input and then try and turn it into an integer, and they actually give us something that is not a correct integer. For example, in this case, we said, give me a non-zero integer, and they gave us 0. So when we tried to divide by that, we got a zero division error. So you're always going to make errors sometimes when you code, but today we're going to talk about try and except, which is going to help you handle errors a little more efficiently in your code, especially when they're errors that we expect. Everything indented under this in the try block is going to try and execute just like normal. And basically, as the name implies, we're going to try to run this. But if it doesn't run, basically if there's an error in the process, we're going to go to this except block immediately. So whichever line that throws the error in this try block, we're going to stop there, not run any more of the code, and go immediately to the except block. So in this case, we're going to say try getting a number from the user and dividing 5 by that number. And if at any point we hit an error, maybe a zero division error, or maybe they give us something that's not an integer, then we're going to go and hit this except block. In this case, it's going to print out this is not a non-zero integer. So the beauty of try and except is that when an error happens in our code, typically Python is just going to stop running your script entirely. In fact, that's what happened the first time that we ran this bad code here. The try and except allows us to continue our script even when we hit an error. In this case, you can see that our script did finish running. It basically just said, give me a non-zero integer, and when that didn't happen, said, this is not a non-zero integer, and finished running instead of just breaking out of the entire script. So in the past, we've used things like while loops to check user input. For instance, this is an example of something we might have done. We might have said, okay, while num not found, so while they didn't give us a number that we consider appropriate, we might tell them, first of all, whether or not that's a good number. So we're saying if the number dot strip minus, this is just allowing them to also give negative numbers. So if it's not numeric, is numeric, right, returns true if all of the characters in the string are numeric. So if that's not the case, if they gave us something that isn't a number, then we print out, oh no, that's not a good number. And then we say, give me another number. Else we can check. So if they gave us a number, but it's not actually positive, we can tell them again, oh no, that's not a good number. Please give me another number. And then finally, if they did give us something, we would say, okay, turn that into an integer and go ahead and end this while loop so that we can say 5 divided by that number, which is what we just want to do all along. Now, this is what we've been doing so far, but we can modify this code to use try and except and make it a little cleaner. All right, so this is what we would have done before, but let's go ahead and rewrite this with a try and except. So we're first going to put our try, the keyword try, a colon, and then inside this block is basically what we would want to run if everything went smoothly. So we're going to say num equals int num, and then we're going to say print 5 divided by num, because that's what we wanted to do. And then we will say num not found equals false, because this will end this while loop. Then we're going to say except, so this is if any error is hit at any point in the try block, we're going to say print, and we're going to say, oh no, that's not a good number. And then we're going to say num equals, and I'm going to copy from up here. We're going to ask them to give us a new integer, hopefully a good one this time. All right, so you can see that we're accomplishing basically the same thing. This is what we want to do, ideally, is like print out 5 divided by the number they give us. But if they, for instance, give us 0 or give us something that's not a number, this try block will exit, go to the except block, and we'll basically say that's not a number and ask them for a new one, which is kind of what we were doing up here. So you can see try and except can not only save you a lot of time, it can also make your code a little more elegant. All right, so let's talk a little bit about multiple exceptions. So far with try and except, we've seen one try block and one except block. but that doesn't have to be the case. Let's think a little bit about the simple example that we just did in Atom. We're basically asking the user to give us a positive number and then dividing 5 by that number. Now, a couple of things can go wrong in this case. First, we could get a zero division error. If the person puts 0 as their number, even though we asked them for a positive number, then the zero division error is thrown. On the other hand, if they, for some reason, type something out or even type out their number, like TEN, then we'll actually get a value error. That's going to hit when we try and turn it into an integer, because Python's going to say, well, I don't know how to turn that string into an integer. So there are two very different types of errors that we expect might be thrown if the user does something that we don't want them to. And we can actually specify what we want Python to do when it hits a certain specific type of error. So I'm going to go ahead and copy the first part of what we had above. So I'm again asking them for a non-zero positive integer. And the first part of my code is going to be exactly the same. So you can see here inside my while loop, my try block is the same as above. What's going to be different is my except blocks. And notice I said blocks plural. All right, so one of the types of errors that we might find is a value error. This happens when the thing that the person enters is not actually a number. So if we hit this error, we can say except value error, right? Because that's the exact type of error that we got. And then we can say print, and I'm going to copy this in. We're going to say print, unfortunately, that is not a number at all, because this will tell our user, hey, you put in something that didn't work, and it's not even a number. So we're going to print that, and then as usual, we are going to ask them to input a new number. But that's not the only type of error we can get. So we can also say except zero division error. And this is basically saying, okay, well, if you get a zero division error during your attempt at the try block, then this is what you'll do. And in this case, we don't need to print the same message, right? We're not going to say, unfortunately, that's not a number, because 0 is a number. What we're going to say is that's 0, and then ask them for a new number again. So I'm going to go ahead and comment out this first one, and then let's go ahead and run this and try it out. So we're going to say Python 3 files and exceptions blank. Okay, so it's saying please give me a non-zero positive integer. And the first thing that I'm going to do is just try and give it something that's not even an integer. I'm going to type in 10. Okay, so you can see it didn't exit out of our script. Our script finished running because we had this try and accept block. And basically that says that is not a number at all. Give me another number. Okay. So I think they want an actual number, not for me to type it out. So I'm going to try 0. Okay, so this time we printed that 0. You can see that when we tried 0, the zero division error, which would happen on this line in the try block, makes us go and hit this except zero division block. And so you can see we printed out that's not 0, and finally we've asked for another number, and okay, let's give it to them. Let's give them 20. Okay, beautiful. Our code finally exited the while loop because we gave it a number that is a positive integer. And you can see here that it printed out 5 divided by 20, which is 0.25. All right, let's try another example. So here I have a list, maybe this is like a grocery list, and I'm gonna write a function. I'm gonna say def item getter a list and index. So this function is a little redundant, but basically what it's going to do is it's going to grab an item if from an index. Okay, so let's use our try and accept block. So what we basically want to do is print a list bracket index. So if we are calling this function, we would essentially have to give it a list and then an index. So for instance, we could say item getter my list and say the thing at index 0. Now this, when we run it, should grab us the string apple because it is printing out the item at index 0 from the list we gave it, my list. But a couple of things can go wrong here. Let's see what it looks like when things go right. We're gonna run, and you can see it printed out apple for us. Now, what if I say, grab me that item at index 20? Well, okay, this only has 4 items. Let's see what happens. I'm gonna run. Okay, we get an index error. Keep that in mind, but we're gonna try again. The last thing that we can do is say we for some reason give it a string apple because we're confused about what the function does. Let's see what happens when we do this. Oh, okay, we got a type error because we're trying to index a list with a string, which is not something that is possible. And indices of lists have to be numbers. So we just saw 2 different types of errors that we might get when running this code, an index error and a type error. Let's use try and except with multiple exceptions to try and fix this within our function. So the first thing that we're going to add is a try block, and inside that try block we're just going to put the code that we want to execute ideally. Then we're going to say except. And instead of just a plain except, let's write exceptions for the specific errors that we saw. The first one was a type error. And so this is going to run anytime Python hits a type error, which happened when we accidentally gave Python a string for the second argument instead of an index, which is an integer. So in this case, we're going to go ahead and print out, that is not an integer, you weirdo. Now, the other option of error that we saw, except, is an index error. So we're going to say except index error. And this is basically what happens when you give it a valid number, you give it an integer, but you give it an integer that is too big, that doesn't exist in this list. So in that case, we're going to print O. So unfortunately, that index doesn't exist. So you can see now that we have this try and except, our code should not throw an error when something bad happens. It should just execute these except blocks. So let's go ahead and save it and try again. Okay, so I need to actually change it, but you can see when we called it with apple, which is a string, not an integer, it said, that's not an integer, you weirdo. So notice it didn't throw an error, our script didn't stop. It completed, it just executed this except block instead of the try block. Now let's try again with 20, because that's what we did before. And again, we know that there's not 20 items in this list. And you can see that says, oh, so unfortunately that index doesn't exist. So you can see that this is really useful. Try and except, and with multiple exceptions, allows us to basically have a way for our script to continue when typically there would have been an error. And with multiple exceptions, we can specify what to print out to the user and what to do in different cases when we have different errors. This is really helpful because you can use these print statements to give the user an idea of what went wrong. And so the better your little print statements that you're printing out to the user are for these exceptions, the more information they're going to have to fix their script when they run it the next time. And I'm sure all of you very much appreciate well-written error messages, so try and write them well yourself. All right, so we've talked about what to do when you hit an error in your code. Let's now talk a little bit about actually raising errors yourself. This is basically a way for you to tell Python, hey, if this thing happens, return an error, make an error happen. All right, so I have this function that might look familiar to you. It's called direction getter. We're going to print, welcome, you've entered a cavern and there are 4 hallways in front of you. And then we're going to ask them which direction you'd like to go, north, south, east, or west. Now, previously what we would have done is say something like, if their direction that they entered isn't in this list, and actually we don't even need all of these, we just need an S, E, W, and we would just say, that's not a direction, you fool. And so we can now actually do something a little stronger. If someone enters something that we didn't want them to, that is not north, south, east, or west, we can actually throw an error. So I'm going to go ahead and copy this function, but I'm going to call it direction getter 2. And here I'm going to teach you how to raise an error when something happens that you don't want to happen. So we have the exact same code, but now instead of just printing to someone like that's not a direction, we are going to use the keyword raise to raise or throw an error if this hits in someone's code. So we're going to raise, and the type of error I'm going to give is a value error. You can give whatever type of error you think is most appropriate in the situation. In this case, I think a value error is appropriate because you're basically saying there's something wrong with the value of the string that you gave me. And then inside the parentheses of this, you're going to print out basically what the error is. So again, you want to write good error messages. So for instance, in this specific case, I'm going to say that's not a valid, there we go, direction. So you can see these things are very similar, but in this case, we have now raised a value error instead of just having a print statement telling the person that they're wrong. This is really helpful because basically if they do something like this, if they put a non-direction, we don't want to continue. We want to throw an error so that our script will stop and they will know that they have done something wrong. So I'm going to go ahead and I'm going to call both of these functions. So we're going to do this twice, once the original way and once with our raised value error way. So let's save and run. So this is the first original way. This is just saying, would you like to go east, west, south, or north? I'm going to say K. And it's just going to say, that's not a direction, you fool. And then in the second case, again, this is the one with our raised error, I'm going to again put K for the direction I want to go. And you can see that this threw an error. It threw a value error saying that's not a valid direction. So you can see that the thing that you put inside value error, the actual error message that will print out, is very important because it will help your user know what they did wrong and how they can change it in the future. So now that we have a raised error inside of our function, we can use this a lot more efficiently in, say, like a try and accept block. So for instance, we could say try d equals direction, there we go, getter 2. And this is going to ask the person for a direction. And then we're going to say accept value error as exception. So this is new. So when you say accept the name of the error and then as exception, basically it stores this message that you put into the value error into this variable exception. So when we run this, if we get this value error, then exception is going to be equal to the string that's not a valid direction. So we're going to want to go ahead and print exception. So we want to print out for them like what they did wrong. And we're going to say print, print I'll give you one more try, and then ask them, for their direction again. So let's comment this call out because we don't need that anymore, and let's go ahead and run it. So you can say you've entered a cavern, there are 4 hallways in front of you, where would you like to go? I'm going to put K again. And it's going to say that is not a valid direction. So it basically printed out what went wrong, but instead of just stopping the script with the error, it's running this accept block. So it says, I'll give you one more try. Which direction do you want to go? And this time I'm going to be nice and say N for north. All right, so we can also use these functions that raise errors in something like a while loop. I'm going to say d equals none. So this is going to be where we store a direction, but we currently don't have one. So I'm going to say while d not in list n n e e s s w w. So this is basically going to create a list of each individual character. So I'm saying while their direction is not one of the appropriate directions. And then I'm going to go ahead and copy and paste our try and accept from before. So let's go ahead and uncomment and move. So basically this is saying try and ask them for a direction. But if you get an error, go ahead and print out what that error is, tell them you'll give them one more try. And we actually don't need this anymore because this is just going to loop again and hit this try block and ask them for a new direction over and over and over till they finally give us a correct direction. So let's go ahead. So let's go ahead and run this, and we're gonna go Python, there we go. So we've entered a cavern. I'm gonna put direction as K. Ooh, it didn't like that. It's gonna ask me one more time. I'm gonna say direction is K. Didn't like that. I'm gonna put blah, blah, blah. There we go, didn't like that. All right, finally, I think I get the point. I'm gonna put W for west, and it finally liked that. So you can see that raising errors in your code, and especially in functions that you're going to use in your code, is a really great way to both tell the user what they did wrong more specifically and be able to take advantage of things like try and except when you use them in your code. All right, so now let's do another example of raising errors. And we're going to go back to that example we saw at the very beginning of our lesson. So I'm going to go ahead and comment this out. And I'm going to write a function, def divide 5. So this is going to grab a number and divide it by 5 like we were trying to do above. So I'm going to go ahead and say num not found, there we go, equals true. And nope, there we go. And then I'm going to say while num not found, and I'm going to say, I'm going to copy this actually from our other script. While we haven't found a good number yet, I'm going to say give me a number. So we talked a little bit before about some things that we can check for if someone gives us a number that is not non-zero and positive. The first thing that we can check for is whether or not that thing that they put in is actually a number. The reason I have this dot strip with a negative sign there is because technically a negative sign is not numeric, but I want to make sure that negative numbers are technically allowed in this. So I'm going to say if not num.strip is numeric, so if it's not numeric, excluding any negative signs, then, okay, well, then they didn't give us a number. So I'm going to raise a value error. There we go. And I'm going to say, oh no, that's not a number. Now, another thing that could go wrong, we'll say if the int num is less than 0, so if they gave us a negative number, then we're going to go ahead and raise another value error, but this time we're going to say positive number expected. Beautiful. Now, on the off chance they gave us something correct, we'll say else, and we'll say num equals int num print, or we'll say num not found, there we go, num not found false, right? Because we have at this point found a good number. And then once this is done, so once this while loop has successfully exited, it means they have given us something. So we're going to say return 5 divided by num. So you can see that this function is doing something similar to what we did in the first part of this lecture. We're asking someone for a number, and then we are checking if they actually gave us a number and if that number is a non-zero positive integer. If they give us something, for instance, that's not a number, we're going to say, oh no, that's not a number, and raise a value error. If they give us a number, but it is not non-zero, it's not a positive integer, then we're going to say positive number expected. Again, even though we're raising two different kinds of value errors, it's super helpful that we have separate messages, because in each case, the thing that went wrong is a little different, and this gives the user more specific information about what they can change next time. But of course, if they do give us a valid number, then we want to execute all of the code to eventually return 5 divided by number so that we can, for some reason, use that later in our code. All right, so now that we have our function defined, I'm going to go ahead and call it and then print out the result. So let's go ahead and run that. So it's going to say, give me a non-zero positive integer. I'm first going to try 0. So I'm going to say 0. Oh, and it's going to say value error, positive number expected. So you can see that this is a very helpful error message. Now I know, okay, I'm going to run this again. I'm going to give it an actual positive number. So I'm going to run it again and I'm going to say, okay, 10 is a positive number. So I'm going to go ahead and give it that. And then it says, oh no, that's not a number. You can see it raised the error that we asked it to. And that gives me a little more information about what Python is expecting. So I'm going to go ahead and run this for a third and hopefully final time and give it the number 20. And you can see that when that happened, we didn't have to raise any errors. And in fact, we just divided 5 by that number and got 0.25. We can also put this in a try and except block. So we can say try x equals divide 5. And then we can say except, and we can say value error as exception. Remember, the exception variable is going to basically store whatever would print out when we get an error. And we can say print exception exception. There we go. So in this case, unlike in the first case, the code won't throw an error and like break. It'll just print out what went wrong for us. So I'm going to go ahead and run this and try it with 0. It says positive number expected. Notice it gave us the same message as it did before, but now instead of like breaking out of our script with an error, we've just seen what actually went wrong. Similarly, if we try this again with 10, you can see we printed out, oh no, that's not a number, but we didn't actually like break out of our script with an error because we were inside this except block, which allows us to kind of continue on with our code regardless of an error. All right, let's finally, no pun intended, talk about finally. So we talked about in our last lecture that when you try and open a file in read mode and it doesn't exist, Python will throw a file not found error because the file doesn't exist. So in this try and accept block, I have try, so try and open and then loop through all the lines in the file. But if it doesn't work, if we throw an error, we can, for instance, say print this error does not exist, this error does not exist, this file does not exist. There we go. And finally, no pun intended, we can do something called a finally block. So we'll say finally, and this basically runs regardless of whether the try or the accept runs. And so for instance, in this case, regardless of whether this runs or this, we're going to need to make sure that we close our connection to the file. So regardless of if try or accept runs, we are going to say poem.close. And this just gives us a way to kind of like wrap things up. Regardless of what happened in our try and accept block, run this to kind of clean things up or tie up any loose ends. All right, and that is all I have for you. I will see you next time.